Hello everybody, welcome back to another navigation video. I know it's been a while since I've made one of these, but with our upcoming CelNav test, I thought it would be a good idea to make another one of these. So today we're going to be talking about diagrams on the plane of meridians for celestial bodies, which is one of the big things that's going to be on this test. I've got two problems for you. I've got an easier one that I've pulled from the homework, and then a slightly harder one that I've pulled from the supplement. And we're going to start with the easier one. Before we get started, there's a couple of formulas that you're going to have memorized. So that is the formula for the GHA of a star, which is the GHA of Aries plus the SHA of a star. The LHA of a star, which is GHA of the star plus east minus west longitude. So if we're in east longitude, we're going to add, and if we're in west longitude, we're going to subtract. And then for polar distance, it's dealing with declination. So if the declination is opposite our latitude, we're going to add it to 90. And if it's the same as our latitude, we are going to subtract it. And then zenith distance, which is the same as co-altitude, is just 90 minus your altitude. So those are the four formulas that we need in order to solve this problem. So we're given this information, and we're asked to find some various information, and we're asked to plot it. So before we plot everything, let's just get all of our numbers set up here. So the first thing is finding our LHA. And we know that the LHA of a star is the GHA plus east minus west longitude. Well, we have the GHA right here, which is 200, and we have our longitude, which is west of 150. So I just do 200 minus 150 is equal to 50 degrees. And that is our LHA. Now, our meridian angle is found by comparing your LHA to whether it's greater than or less than 180 degrees. So if it's greater than 180 degrees, you take your LHA, you subtract it from 360, and then you label it east. If it's less than 180 degrees, like we have in this situation, our LHA is 50, then our meridian angle is just 50 west. Now, azimuth angle. Azimuth angle is labeled by our latitude and our meridian angle. So it's treated just like a course angle, right? So it's north 100 west. Now, what is north 100 west? Well, that's 360 minus 100, so that's 260, and that's our true azimuth. True azimuth is just your azimuth angle evaluated out to whatever is true. Zenith distance. Zenith distance is 90 minus our altitude, and our altitude's 20, so 90 minus 20 is 70. But zenith distance is a distance after all, and that's 70 degrees, so we have to multiply it by 60. 70 times 60 is 4,200. So now we need to find polar distance. Now, polar distance is either 90 plus or minus your declination. And in this situation, our declination is south, our latitude is north, so that's an opposite. We're going to add them. So we're going to go 90 plus 15 is 105. Now, that's degrees. Polar distance is a distance. So we have to do 105 times 60, which is 6,300. And then another thing that we can check here, although it's not listed, but when we do our final triangle, it'll help us to kind of make sense of things, is figure out what our co-latitude is, because that is one of the legs of the triangle after all. So co-lat is 90 minus our latitude. So that's 90 minus 40 is 50. And co-latitude is a distance, so we're going to multiply that by 60. It's 3,000. Now, with all those numbers that we've just calculated, we can now go to these diagrams. So the first one we're going to do is our time diagram here. And the first thing that I like to do with the time diagram is just remember that that way is west and that way is east. So I like to put Greenwich in first. Well, Greenwich is going to be based off of our longitude. Our longitude is 150 west, which means that Greenwich is 150 east of us, because this is all, remember, relative to us. So each one of these tick marks is 30 degrees, so 3, 6, 9, 12, 15. That's G, and then we have a dotted line for little g. Okay, now we're going to plot the star. And we know what our LHA of the star is, which is also T. It's 50 degrees, and it's 50 degrees west. So that's 30, and that's 60. 50 is going to be right about, say, here. That is our star. So now we've got to put in all of our angles. Well, longitude is Greenwich to us, right? So that's longitude. And then Greenwich west to the body is Greenwich hour angle, right? So we're going to put that in here. It's GHA. Sorry, I'm doing this on an iPad, so my image is quite bad. And then from us, west is LHA. But when LHA is less than 180, T is equal to LHA. So that's LHA and T. So that's our time diagram out of the way. Now we have to do the more complicated horizon diagram. So we start by, I like to put the poles in and the equator in first, because you kind of need to do that before you do anything else. So let's start with the poles. So we know that we're 40 degrees north. We're going to go north up 40. And this is a picture, so although it doesn't run straight through the middle, it's supposed to, because it's just a picture. It's a little lopsided. So there's two ways that you can do that. You can either say, oh, well, it's 40 degrees north, or you can say that the pole is an additional 50 degrees north of us if we're at 40 degrees north, so you would count 50 this way. So this is pole north, and this is pole south. And we know that the equator, if we're at 40 degrees north, the equator is going to be 40 degrees south of us. Okay, so now let's plot the diagonal circle of our body here. So we know that the declination is south 15. So we go to the equator, and we're going to go 15 south. So we know that relative to the equator, or relative to the celestial equator, the equinoctial, it's 15 south. But then we have to keep in mind that there's a horizon, we're observing it. So we have to figure out its altitude, which is 20. So this plane, this north-south plane, is our horizon. So we're going to go up from our horizon 20 degrees. And this point right there, where our altitude and the circle of the body intersect, is where the body is in the sky. So from there, I have to draw my navigational triangle, right? And there's three vertices in the navigational triangle. It's your zenith, pole, and the GP of the body. So we're going to draw it like this. Okay, so now we have the sides drawn in. And we have to then label the sides. Well, from our zenith to the pole, well, that's just co-latitude, right? Zenith to the body, that's zenith distance. And then from the pole to the body is polar distance. And then the angle from our co-latitude line to our zenith distance, it's z. And then from our co-latitude to our polar distance is t. And there we have it. And we can confirm that these make sense by going back and looking at the distances that we calculated here, right? So polar distance here, 6,300 nautical miles. That should be our longest, and it definitely is. That should be followed by zenith distance, which is 4,200, yep. And then our co-latitude of 3,000. You can see everything all checks out here. It all makes sense. So that is a very simple problem that you can, visualize here. That's, again, right out of the homework. So now we're going to go to something a little bit more complicated. And I saved this for later in the video because I don't actually have confirmation. I don't have an answer key for this one. So if I screw it up or anything like that, I won't know. So if I do screw it up, please let me know down in the comments. Or just message me on Messenger, because everybody who's watching this knows me. Using the same formulas from earlier, let's figure out what the LHA of Arcturus is. Well, first of all, we have to figure out what the GHA of Arcturus is, because it doesn't tell us, but it tells us GHA and SHA. And from there, we can figure out what LHA is. So we can say that the GHA of the body, right, is the GHA of Aries plus the SHA of the star. So 131 degrees, 45 minutes, plus 146 degrees, 18 minutes. That's 278. So that is the GHA of Arcturus. So now we got to figure out what the LHA is. And the LHA is just GHA plus G minus longitude. In this situation, our longitude is east, so we are going to add 100 degrees, 30 minutes, 378, and 33 minutes. Well, 378 degrees, 33 minutes. Well, that's a problem. You only have 360 degrees. So we have to take 378 degrees and subtract 360 degrees from it. 18 degrees, 33 minutes. So that's the LHA of Arcturus. And remember what we said about T. If your LHA is less than 180 degrees, your T is the same as your LHA and it's labeled west. And now we have our azimuth, which is going to be labeled with our latitude, which is south, and our T, which is west. So our true azimuth is going to be south 160.5 west, which is 180 plus 160.5, 340.5 degrees. Now our zenith distance, well, our zenith distance is just our co-altitude, right? So we are going to take our altitude, which is h, and we are going to do 90 minus that. So 89 degrees, 60 minutes, minus 26 degrees, 05 minutes, and our zenith distance is 63 degrees, 55 minutes, but remember, zenith distance is a distance, so I have to convert that to nautical miles. 55 divided by 60, I'm just doing this on a calculator. 55 divided by 60 plus 63 is 63.9 times 60 is the 835 nautical miles. And now we have to figure out polar distance. Well, polar distance is just 90 plus or minus your declination. In this situation, our latitude and our declination are opposites, just like the previous example, so we're going to add them. We're going to do 90 plus 19 degrees, 17 minutes, 109 degrees, 17 minutes. But again, that has to be converted to nautical miles, so 17 divided by 60 plus 109, which is 109.28, multiplied by 60, gets me to 6,557 nautical miles. And then finally, our co-latitude is just 90 minus our latitude, 4740, which, again, 40 divided by 60 plus 47 times 60 is 2860. Okay, so with all of this, let's do our diagram. So let's start by plotting Greenwich. Our longitude is 100.5 east, which means that Greenwich is 100.5 west of us. And we know that the T of the body is 18.5 west. But remember that Aries is involved here. I'm not going to plot Aries, but if you did, I'm just looking at my notes, the local hour angle would come out to like somewhere over here. And you would calculate the local hour angle of Aries by the same thing, GHA plus minus longitude. The LHA would come out to 232 degrees 15 minutes, and T would come out to 127.45 east. And then with all of this, we can do our time diagram. So let's first do this. This is LHA. It's also T. That angle, longitude, that is GHA Aries. That is SHA. That is GHA star. Okay, so with our time diagram done, let's move down to our horizon diagram. Now, we're going to keep things to whole degrees here. We're not going to go decimals because it's just not worth it. So our latitude is 42 degrees 20 minutes. We can round that down to 42 degrees. So south up 42 degrees. All right. So this is P south, P north. And now we're going to do the equator, which we know if we are 42 south, we know that it has to be 42 north of us. All right, and now let's plot our declination and our altitude. So our declination is 1917. We'll just call that 19. 19 north. So from the equator, we are going to go 19 north. That is our star. And now we've got to plot our altitude. 26 degrees, 5 minutes, we'll just call it 26 degrees above here. And it comes out that the star is right there. So now we're going to draw in our triangle like we've done in the past. And we know from last time that between our pole and zenith is our colat. Between our pole and our star is our polar distance. And between our zenith and star is our zenith distance. And between our co-latitude line and our zenith distance line is our azimuth. And between our co-latitude and our polar distance is our meridian angle. And we can check those angles real quick by just looking and seeing that T is 18. That's a pretty small angle, and that's a pretty big angle for Z 160, right? Yeah, that's that. Again, I have nothing to check my answers on here, so if I'm wrong, I'm wrong, but this is the general process. Even if I've made a mathematical error, I still have the general process correct. I doubt that they're going to give us one of these diagrams on the test, but just in case they do, I'll attempt to diagram one out real fast. So South Pole, and we have that my declination is north, so it's going to end up being like here. And then we know that we are east. So if we're east, that puts us over here in the southern hemisphere like that. And then we have that. So this, that, there's the GP, this is our AP, and that's the pole. Where this would be our zenith distance. This would be our colat. That's that. Alright, that's everything I've got for this video. I know it's probably lower quality compared to my other videos, and I also don't understand it as well as I understood some of my other concepts, but hopefully that was helpful for your studying purposes. And I'll catch you in the next one, whenever that next one is. See ya.